All right, here we go. Next lesson, we're going to talk about finding the area of regular polygons in this lesson. This is typically an honors only assignment. So CP students, if you didn't follow instructions in class or instructions on Canvas and you just kind of were looking around at Mr. Oates' videos and happened to stumble upon this one, you probably aren't required to watch it. However, if I did tell you in class or on Canvas, then yes, you are. So, usually just an honors lesson though. This is it gets a little bit involved. We come back to some trigonometry. There's a multi-step process. It's like 6 steps long. So I'm going to do 3 examples in this video. I'm going to introduce one term, kind of a second term that's a little bit different usage than we've used before. And then I'm going to walk you through the 6 steps with each of the 3 examples. All right, so here we go. First thing is apothem. That's our new term. A-P-O-T-H-E-M, apothem. Kind of sounds like an opossum with a kid who can't quite say the word right or whatever. All right, but apothem. Okay, now what's an apothem? Okay, here is a regular shape. I know I kind of did this hexagon by hand, so it doesn't quite look regular. Remember, regular means equilateral and equiangular. Okay, and this side down here is probably a little shorter than that side up there. But main thing is you understand what an apothem is. An apothem starts at the center point. It comes out to the middle. It's got to be right in the middle, so maybe I could put congruent marks here and here. Okay, the middle of a side, and it must meet it at a right angle. So I'm going to go ahead and put those congruent marks right here. All right, so it's basically like a perpendicular bisector that starts at the center of a regular polygon. All right, now a couple other things that will show up are, this is a term we've already used, radius. But we're very used to seeing the term radius in a circle. Here we have the radius of a polygon. Now the radius of a polygon is this distance right here, out to a corner. Okay, so the radius starts at the center and comes out to the corner. The apothem starts at the center and comes out to a midpoint. If you were to do a circumscribed circle, remember the circle that goes around the outside of a shape? The radius is the radius of the circumscribed circle. The apothem is actually the radius of the inscribed circle. So if you were to put a circle inside the polygon, in this case the hexagon, if you put a circle inside the hexagon so that it touches every side exactly once, the radius length of that circle is the apothem. Okay, so if you think inscribed, circumscribed circles, we've done those before back when we did, especially with triangles, we did in-center and inscribed circles and circumcenter and circumscribed circles. Okay, capital P is the perimeter. All right, capital P is the perimeter. Why do we use capital P for it? Just kind of something we do. I don't know that there's a great reason for it. Okay, and then you're going to see this variable x show up in our problem. I want to show you where x is. Okay, this right here is x. Okay, just that distance, half of the side length. Okay, so x is half of the side length. So those are the things that are going to show up in our formula. Now the formula is this. I'm going to write it right over here. Area equals 1/2 times A times P. Okay? And you'll be like, well, R is not in there anywhere. You're right, R is not in there. We do not use the radius in the formula. We may use the radius to help us find maybe the apothem or the perimeter. We definitely use X to help find the perimeter. Okay? So radius and X don't show up in the formula, but they help us find pieces of the formula. Now the reason this works real fast, if you were to take just this triangle, right, 1/2 times base times height, okay, the base is x, the height is a. Okay, so already we have 1/2 times the height. If we were to draw a bunch more triangles, so I drew out to here, and then like I drew another apothem out to here, the apothem can kind of go any direction, and another radius out to here, an apothem and a radius and an apothem and a radius and so on, all the way around the shape, I would get a bunch of triangles. Well, if I want to add up all of those triangles' areas together, I would get the area of the whole shape. And if I add up the base of every triangle, this x and that x and that one, remember there'd be 2 triangles over here with the apothem, okay, and 2 more x's and 2 more, and so on. If I add up all of the bases of all of the triangles I create, I get this. So what this P has done is it's combined all of the triangles together for us all at once. So it's just 1/2 times all of the bases of all of the triangles together times the height of each individual triangle. So it's really just based off the area of a triangle formula. Okay, 1/2 times base times height. All right, so that's our formula. So now I'm going to show you the steps we're going to use, and then I'm going to start to apply the steps. So let me just walk through the steps first. Steps to use our formula. First off, we are going to draw the small right triangle. What do I mean by the small right triangle? It's this one, the AXR triangle. That's our small right triangle. Okay, small because it's the smallest kind of one I can get inside this shape that makes sense to use. It's a right triangle because I'm going to have a right angle right here. Okay? Then I'm going to find the top angle. Now what do I mean by the top angle? I mean the top angle of the triangle, this one right here. We're going to find that angle. And the way we're going to find that angle is all around the interior would be 360 degrees. Okay? If you think about it, I have, if I were to draw this other radius, okay, I basically could have, and if I keep drawing more radii, remember radius, plural is radii, if I were to draw more of them, I'm not drawing the other apothems yet, I would end up with 6 triangles. 1, 2, 3, 4, this one together makes 5, and then 6. Well, if I do 360, the whole thing divided by the 6 triangles, that would take the angle from here all the way over to there. Then all I got to do is cut that in half. So to find the top angle, what we do is we take 360, we divide it by my number of sides, n is the number of sides, and then I take that divided by 2. Okay, so 360 divided by the number of sides would give me the angle that starts here and goes all the way over to there. And then when I cut that angle in half, I get just that angle. So that's how we find the top angle. All right, next we're going to find A, and we're going to find X. I usually do them in that order, all right, because immediately after X, I'm going to use X to find P. So I usually find A first, then I find X, and this could involve special triangles, our 30, 60, 90 triangle, or our 45, 45, 90 triangle. Okay? If it's not one of those special triangles, then it's going to involve trigonometry. Okay? Use X to find P. All right? And then once I already have A, and once I have found P, I'm going to use A and P in my formula. So those are the steps we're going to use. I'm going to do an example for you. I'm really going to do 3 examples, and I'm going to walk through each of those steps as I do the example. So we're going to start with a hexagon that has a side length of 8. And I may bring that list of 6 steps kind of back into the picture every now and then so you can see what's going on. Hexagon side length of 8. So the very first thing I'm going to do, remember step 1, okay, draw the small right triangle. Okay, so I'm going to draw straight down for the apothem. I'm going to draw my right angle. I'm going to come over here for my radius. And I'm going to go ahead and put X and A and R into my picture. That's a small right triangle. Now usually what I'll do is I'll even draw that off to the side here so I can do some work on it. Okay, so off to the side, I'm going to redraw that triangle. And to be honest, in the long run, you'll see this in the last example, I don't even draw the shape. So that's A, that's X, that's R. Okay, next we find the top angle. Okay, remember 360 divided by n and then divided by 2. So 360 divided by 6, my number of sides on my hexagon is 60. And then 60 divided by 2 gives me 30. So this angle up here is 30 degrees. Now this angle, pretty easy to find. You don't have to find that angle all the time. All right, this one's easy, it's a 30, 60, 90 triangle. Okay, but you don't even need to find this angle all the time. Okay, 60. Find A. Okay, now, to be honest, finding X is easier here than finding A. All right, and we're actually going to use X to find A. It just happens that we do it kind of out of order. All right, so we're gonna find A and we're gonna find X. Now we were told that the side length was 8. That means from here all the way to there is 8. So that should be really easy. X is going to be 4. So X just equals 8 divided by 2. So X is 4. We are going to now do our 30, 60, 90 triangles with our 1, our root 3, and our 2. Remember the 1 always goes across from the 30, the root 3 goes across from 60, and the 2 goes across from the 90. So if I want to solve for A, I'm going to set up my proportion. A over root 3 equals my 4 over my 1. I cross multiply, I get A equals 4 root 3, and I have found A. I always kind of put a star next to A because it's going to show up in my formula again. All right. Next, I'm going to find P. Remember, step 5, use X to find P. Now, some of you may wonder why I do this the way I do it, but it's because in the long run, it's helpful every single time. Some of you would be like, oh, a perimeter, I just do 8 times 6, it's 48. Yeah, you can, all right? But I'm going to show you another way to find P that will help in the long run, okay? So let me just show it to you. You'll see it, especially when we get into some of the harder ones, okay? Now, P, to find P, I'm always going to take X and I'm going to double it to get back to the side length. So it's always 2 times X, and then that's the whole side, and then I multiply by N, the number of sides, to get the final perimeter. So it's always 2 times X times N. This is always P, okay? So in this case, P would be 2 times 4 times 6. We already knew X was 4. We know N has, for a hexagon, is 6 sides, and the 2 is just always there. We use the 2 because we're doubling this to get back to the whole side length. I put a star next to this because A and P are what I actually use in my formula. Finally, area equals 1/2 times A, 4√3, times P, 2 times 4 times 6. Now, here's why I don't multiply this all out and get 48. Because that 1/2 and that 2 will always cancel each other out. If I have a 48 here, then I gotta think through the 1/2 and the 48 a little bit more. All right, if I just leave it as a 2, I know that this and this will always cancel. Now, these are not like terms, but we can still multiply unlike terms. You can't add or subtract unlike terms, but you can multiply them. So all you gotta do is take 4 times 4, 16. 16 times 6 is 96. Put the √3 on there, 96 √3. And a label, I didn't actually give a label on this one, so units squared. Remember, it's area, so squared, 96 √3 units squared. That's the area of that hexagon. That's the process. It's long, I guess, but it's not complicated. Like, you know how to do each of those things. Each of those individual steps are not difficult. It's just a matter of putting them all together. Okay, so let's take a look at another one. This time, we're not going to end up with a special triangle. We're going to end up with having to do some trigonometry. Okay, so we're going to do an octagon. I'm going to put a label on this one, so let's put 10 inches. An octagon with a radius of 10 inches. Now, you do not have to be able to draw an octagon. Okay, if you can draw an octagon, great. If you can kind of come close, great. But really, all you have to do is draw the small right triangle. Remember, that was step 1. Draw the small right triangle. Okay, so the small right triangle comes here to here and out to here. Okay, this is the only thing you have to be able to draw, and that's really easy to draw. Once again, I'm going to draw it off to the side. Okay, this is my apothem. I don't know it. I was told the radius was 10, so that's going to go over here. This is X, this is A. Next, I'm going to find the top angle. Remember the top angle? 360 divided by N divided by 2. Okay, so 360 divided by 8 is 45. And 45 divided by 2 is 22.5 degrees. Now, we don't want to use rounded off decimals, but 22.5 is not rounded off, so we can use it. Now, if this was a 7-sided shape, all right, a heptagon, 360 divided by 7 is a decimal, it just keeps going and going and going, so we would want to leave that as a fraction. And then when I take 360 divided by 7 and divide that by 2, dividing by 2 is the same as multiplying by 1/2. I would get 360 over 14. I'd reduce that to 180 over 7, and every angle would be 180 over 7. That would be a little more complicated to type into a calculator and all that, but it's still doable. We just don't want to use rounded off decimals. So using a 0.5 is okay. So that's 22.5 degrees right here. Okay, I hope you can see that. I put a 22.5 right there. Okay, now I'm going to find A. All right, so let's think through A. This is not a special right triangle. You're not using 45, 45, 90 because the 45 got cut in half. So I've got a hypotenuse and I've got an adjacent side. So what deals with adjacent and hypotenuse? Remember, that's cosine. So the cosine of 22.5 degrees equals the adjacent A over the hypotenuse 10. Okay, if we cross multiply, this is over 1. A times 1 is just A, equals 10 cosine 22.5 degrees. Do not multiply this out and get a decimal, because if you take this as a decimal and use it later on in the problem, rounded off decimals used later on in the problem always cause more problems. So I'm just going to put a star next to this. That's my apothem. All right. Next, I need to find X. Okay, and we're going to come back up here and find X. So X is opposite. I still have the 10, which is the hypotenuse. So what deals with opposite and hypotenuse? That's sine. So it's sine of 22.5 degrees. I'm going to put that over 1 equals the opposite over the hypotenuse. X times 1 is just X. 10 times the sine of 22.5 degrees. All right, now remember we use x to find p. That's our next step. Come back over here, remember, use x to find p. If we look back at that previous page, I didn't write it down here. Instead of showing the whole previous page, I'll just put this off to the side. P equals 2 times x times n. Okay? So p equals 2 times this x right here, 10 sine 22.5, times n. Remember, number of sides for an octagon would be 8. I'm going to put a star next to this because all of that is my p. So there's my first star, my a, my second star, my p. I'm going to put it all together into a formula. So area equals 1/2 times 10 cosine 22.5 degrees times 2 times 10 sine 22.5 degrees times 8. It's a lot of writing there. Now, 1/2, 2, always cancel. If you want to multiply the 1/2 by the 10 and cancel it that way, that's fine. It's just a little bit more thinking. I just know 1/2 and 2 will always cancel, makes it super easy. Now, you can type this into your calculator just like this. I'm going to show you how to do that. Or you can simplify it first and then type it into your calculator. Either one is completely acceptable. They should give you the same answer. This is a 22.5, just in case that looks like a 27. 22.5. All right, 10 times 10 is 100. 100 times 8 is 800. Cosine 22.5 degrees, sine 22.5 degrees. I'm going to show you how to type both of those into your calculator correctly. Okay, so either one works. Let me get my calculator out. First off, make sure that you're in degree mode, not radians. So we hit our mode button. Remember our mode button right here? So we hit mode. I'm looking at this right now. It is in degrees. If that black box is on radians instead, you're going to get all these wrong. You don't know what a radian is. We want to make sure that's on degrees, just like that. Okay. If I'm on degrees, I can hit clear or second. Quit works as well. Okay. So now I'm going to show you the first way, the long way. 10 cosine 22.5 times 10 sine 22.5 times 8. So 10 cosine 22.5. You must close that parenthesis. If you do not close that parenthesis, it's going to be wrong. Okay, that's very, very, very important. Okay, times 10 sine 22.5. So times 10 sine 22.5. Got to close the parenthesis again. If you don't close the parenthesis, it's going to be wrong. And then times the 8. If you just put 8, that's fine. If you want it times 8, either way, it's both acceptable. And there's your answer, 282.8427125. It just keeps going and going and going. I want you to round to 2 decimals. Let me show you how to do it this way. Okay, 800 cosine 22.5, close the parenthesis, sine 22.5, and see we get the same exact thing. Okay, so 282.84 inches squared. Okay, now I'm going to show you what happens if you don't close the parenthesis. Okay, 10 cosine 22.5. Let's say I close that one. 10 or times 10, it really doesn't matter if you put the times, to be honest with you. Sine 22.5 times 8. I forgot to close the parenthesis, right? 0. That's because 22.5 times 8 is 180, and the sine of 180 is 0, and then 0 times everything else is just 0. Okay, what happens if I don't close the first parenthesis? 10 cosine 22.5 times 10 sine 22.5. I remembered to close that one, times 8. 8.556, very different answer again. It's because what happened is it took this 10 sine 22.5, did all of that math, and then times it by 22.5, whatever that happens to be, and took the cosine of that angle. Obviously, that's not what we want. Last one I'm going to show you is you don't really have to have the time signs in there, so if you just do 10 cosine 22.5, close, 10 sine 22.5, close, and hit 8. All right, remember, if there's nothing between things in math, it means multiply anyways. Gives me the same answer. All right, last one. We're going to go to a dodecagon. I don't want to draw a dodecagon. I don't want to do it. Okay? So, I'm not going to. You don't have to draw a dodecagon. The instructions, steps, they draw the small right triangle. So, I'm just going to draw the small right triangle. There is my small right triangle. It would have been in kind of the center bottom part of that dodecagon. Remember, a dodecagon has 12 sides. The side length is 9. That would go from here all the way over to here. So, x equals 9 over 2. Or you could put it as 4.5. Remember, 0.5s are okay. You just don't want rounded off decimals. My apothem, my radius, got to find the top angle now. So 360 divided by 12 gives me 30 degrees. This is not going to be a 30, 60, 90 triangle. I don't know if all that was in the frame before or not. Sorry. So then x equals 9 over 2, which is 4.5. Got my apothem, got my radius. 365 by 12 is 30. This is not going to be a 30, 60, 90 triangle because remember we got to then divide by 2. We get 15 degrees for the top angle. Okay. Now, I already found x. I'm just going to kind of write that off to the side somewhere. 4.5 or 9 over 2, either one. Okay. Apothem. Opposite, I know. Adjacent, I don't. What deals with opposite and adjacent? That's tangent. So the tangent of 15 degrees equals 4.5 over a. Right, tangent of 15 equals 4.5 over a. Cross multiply, a times the tangent of 15 degrees equals 4.5. A equals 4.5 over the tangent of 15 degrees. Okay, that's important. We're going to use that later on. Perimeter, remember, is 2 times x times n. So 2 times x times n, which is 12. Remember, I don't bother to simplify this here because I know the 2 is going to cancel off later on anyways. We may want to simplify this 2 at some point to make things easier. I'll show you how to do that. Okay. Finally, 1/2, area equals 1/2 times a, 4.5 over the tangent of 15 degrees, times x, or times p. Remember, star here and star there. I didn't star that one before, but times 2 times 9 over 2 times 12. So this 2 and that 1/2 will always cancel. If you want to simplify this a little bit, it's probably going to make things easier. You could type it in just like this right now, or we could do some simplifying, and I'll show you both ways again. Okay, so I'm going to do a little simplifying. 2 and 12, 1 and 6. 6 times 9 is 54. If I go to my calculator and do 54 times 4.5, all right, can you see that? 54 times 4.5, excuse me, is 243. So 243 over, don't all of a sudden put times tangent of 15, it's still over tangent of 15. So I can type it in this way, or I can simplify and type it in this way. This is obviously a lot easier to type in. I'm going to show you that part first. Okay, 243 divided by the tangent of 15. All right, I didn't close that parenthesis. It was at the very end. It still gives me the same answer. I'll show you that. If it's at the very, very end, you can get away with not closing it. If you got anything after it and you don't close it, it's a problem. So you should get in the habit of closing it. I know when I'm allowed to and when I'm not, so that's why I didn't close it the first time. Okay, you're kind of at the point where you might not know when you're allowed to and when you're not. That area, if you saw it, hopefully, or you typed it in your own calculator, 906.89. Let's give it a label, centimeters. Okay, so centimeters squared. Okay, let me show you how to type this part in. I'll show you how to do it with the 6 that we already reduced. I'll also show you how to do it even if you didn't reduce that 2 and 12. So 45 divided by the tangent of 15, close it, right, times 9 divided by 2 times 12. Now, every now and then this can be a problem depending on the calculator. So I don't think it's going to be an issue here. All right. And why is that off? Because I didn't put the decimal in there. See that decimal? I completely forgot. I put 45. Let's try that again. 4.5 divided by the tangent of 15. Close times 9 divided by 2 times 12. Okay, same exact answer, 906.89. All right, now let me show you what happens if you've already done this, maybe 1 and 6. So 4.5, don't forget the decimal this time, divided by tangent of 15, close it. Okay, times 9 times 6. Okay, so I don't have the 9 over 2 in the 12 part. I did that reducing. Same thing. Okay, so there's a couple kind of different ways to type it in at the end. You just got to be really careful that you don't make any mistakes along the way. And that is how you find the area of a regular polygon. I'll probably ask you to do, I don't know, 3 or 4 of those on your worksheet. It's not going to be very many to do. Okay, and that's it for this lesson.